Okay, we are now going to look at linear, area, and volume scale factors. If you think about it, if two things are similar and they have area, they're going to have a scale factor as well, just like a line. Or if they have volume, then they're going to have a scale factor just like a line. For instance, if you had a small glass and it was similar to a big glass, you would know you need to multiply it by a number and you would get a bigger volume. So you're still comparing two things. The first thing to the second thing. You're going to multiply it by a factor to find the second. When we talk about linear, we're talking about a line. So just like before, if we have 1 inch, or let's do centimeters. We do 1 centimeter and we have a scale factor of 2, then we're there going to have 2 centimeters. Same thing for area. If we have, if we have an area, all of this in here, 1 centimeter by 1 centimeter, we multiply that by, let's say, 4. We're now going to have 1, 2, 3, 4 4 centimeters squared. If I do this with volume, if I start with 1 centimeter by 1 centimeter by 1 centimeter, length times width times height, I get 1 centimeter cubed. Let's say I multiply this by 8. If I multiply this by 8, then I need to have 8 of these boxes. 1, 2, 3, 4, 5, 6, 7, and in the very back, I have another one. 8. That's going to be 8 centimeters cubed. This is simply a scale factor. If I'm talking about a line, it's a linear scale factor. If I'm talking about the area, and it's an area scale factor. If I'm talking about the volume, then it's a volume scale factor. So let's say I have a triangular prism. And inside there is 10 centimeters cubed. And I have a scale factor of 7. Then my new prism is going to have 70 centimeters cubed. That's it. I'll just do that. How are these related is kind of where it gets a little bit tricky for us. If I go 1 centimeter here, and I times it by 2, this is now a linear scale factor. So this side here is going to now be 1, 2, 2 centimeters. And this side, which is 1 centimeter, it's going to be 1, 2, 2 centimeters. If I look at this, I can see this is 1 centimeter times 2. Times 1 centimeter times 2 to get over here. So this side times by 2 to get this side. And this side times it by 2 to get this side. What if I think about this in a different way? So if I look at this as the side times the side of the original, 1 times 1, times factor times factor. Because I'm multiplying the factor to each of the sides. So this is length times width, which we know gives us the area, times the factor times the factor, or factor squared. This means that the area of the original times the linear scale factor squared will give me the new area. 1 times 1 is here. And 4 centimeters is here, which is 1 times 2 squared. Okay. From there, we're going to look at now how that works with volume. So it's the same situation. If we have 1 centimeter by 1 centimeter by 1 centimeter, this then creates a volume for us. Length times width times height. 1 centimeter by 1 centimeter by 1 centimeter. If I am then multiplying that by a linear scale factor of 2, let's say, then my 1 becomes 2 for the height of this. For the length of this, my 1 becomes 2. This is 2 by 2. And the width of this becomes 2. So this is now 2 as well. That's kind of a wonky one, isn't it? So now instead of 1 times 1 times 1, I have 2 times 2 times 2. And what happens there is I take my side length of 1 and multiply it by the factor of 2. And then I take my width of 1 and I multiply it by a factor of 2. And I take my height of 1 and I multiply it by a factor of 2. Length times the factor times the width times the factor times the height times the factor. If you see here, I've got 3 factors. So I'm just going to separate this a little bit differently. Length times width times height. This is the original, right? Times factor times factor times factor. I have all the same pieces, but you'll notice here this is factor cubed. So I have my original volume. I times it by the linear scale factor cubed, and I'm going to get the new volume. Now, moving from there, I'm just going to rewrite this for myself. Linear scale factor is for lines. Area scale factor is for area. And volume scale factor is for volume. The area scale factor is equal to the linear scale factor squared. And the volume scale factor is equal to the linear scale factor cubed. Volume scale factor cube root and then squared is equal to the area scale factor. And I can say that the square root of the area scale factor cubed is equal to the volume scale factor. The linear scale factor is equal to the cube root of the volume scale factor is also equal to the square root of the area scale factor. That's how you go backwards. If given the area, you can square root it and you can find the linear. If given the volume, you can cube root it and you can find the linear. They go back and forth. Linear cubed is volume, and the cube root of volume is linear. They're the opposites of each other. So when I look at this is connected to this one. When I look at this one, it's connected to this one. Square and square root, cube and cube root.